Hello student. So in this video I will solve a question from JEE Advanced 2019 paper 1. The question is all about to determine the acid strength of the carboxylic acid. Okay. So the question is the correct order of acid strength of the following carboxylic acid is, and they have given 4 different carboxylic acid and we have to determine the acid strength and we have to arrange them according to the acidity order. Okay. So before solving the question, we have to know some basic concept of acidity of carboxylic acid. Now, suppose there is a carboxylic acid like this RCO2H. This is a carboxylic acid. This R group may be aliphatic or aromatic, whatever be it. Whenever there is an acid, so the main characteristic is it will generate proton or H plus, and it will form the corresponding anion and H plus. This anion is known as conjugate base. Okay, and this is our as usual acid. Okay, so to determine the acidity of this carboxylic acid, we have to determine the stability of this conjugate base, because the acidity is directly proportional to the stability of conjugate base. Okay, so higher the stability of the corresponding conjugate base, higher will be the acidity of those carboxylic acid. So you have to be very clear about this concept. Higher the stability of the conjugate base, higher will be the acidity of the corresponding acid. Okay, now we have to solve this question. So there are 4 different type of carboxylic acid and each one will produce their corresponding conjugate base. So there will be 4 conjugate base or anion. The first acid will produce this conjugate base. The second one will produce this conjugate base. The third one will produce this one. And the fourth one will produce this one. Okay. Now we have to determine the relative stability of these 4 different conjugate base. Okay. Now we have to determine this stability according to the inductive effect and mesomeric effect. Now in the first case, the carboxyl group is attached to this carbon atom, which is our sp hybridized. In the second case, this carboxyl group is attached to an sp2 hybridized carbon atom. The third case, it is the carboxyl group is attached to an sp2 hybridized carbon atom, which is part of an aromatic ring, and there is a methoxy group which is also attached at the para position of this aromatic ring. And fourth case, the carboxyl group is attached to an sp3 hybridized carbon atom. So this is our alkyl group, and we know that every alkyl group has plus I effect. Plus I effect means this alkyl group will pushes electron density towards this carboxyl group. So as a result, the electron density will be increased in this position, so the stability will decrease. So this conjugate base is the least stable among all those conjugate base. So this is our least stable. And we know that the acidity is proportional to the stability of conjugate base. So as this anion is the least stable, so the corresponding acid will be least acidic among all. Okay, so option 4, that is the acid 4 is the least acidic among all three. So in option A, B, C, the 4 is the least acidic, but in option D, they have given the acid 3 as the least acidic. So this option is wrong. Okay. Now we have 3 option and 3 conjugate base left. Now this is sp hybridized and these two center are sp2 hybridized. And we know that for sp hybridized carbon atom, the percentage of S character is 50%. And for sp2 case, the percentage of S character is 33%. And as the percentage increases, the electronegativity of those corresponding carbon atom is also increases. Okay. So for this case, this carbon atom is much more electronegative compared these two carbon atom. Okay, because the percentage of S character for this carbon atom is 50%. Okay. So this one will attract electron density from this carboxyl group and it will stabilize this carboxyl anode. So among these 4 options, this conjugate base is the most stable. Okay, and we know that acidity is directly proportional to the stability of conjugate base. So the corresponding acid 1 will have the highest acid strength among all those acid. So in option A, they have given the option acid 3 as the highest with acidity, but this is not true. Now we have option B and option C. Now we have to determine the acid strength of these two acid. Now if we see that both are sp2 hybridized, here also and here also, but in this case of this aromatic group, it is attached to a methoxy group, which is an electron donating group. Okay, so due to this electron donating nature, it will pushes electron towards the aromatic system and towards this carboxyl group. So as a result, the electron density will increase in this carboxyl group. So the stability will decreases. Okay, so among 2 and 3, the stability of 3 is less compared to 2. As the stability of this conjugate base is less, the acidity of 3 will also be less compared to 2. So 2 is more acidic compared to 3. Clear? Now in option B, it is given that option acid 2 is more stable than acid 3, but in option C, they have given acid 3 is more acidic than acid 2. So this is not true. So our correct answer is option B. Okay. So this is a very conceptual question. We must have an idea of acidity, inductive effect and electronegativity. Okay. So in this video or in this solution, if you have any doubt or any queries regarding the solution, please comment below.